Good morning, guys. It's Miss Bentley, and I'm here today to go over factoring difference of squares. So I'm going to start out with reviewing what produces difference of squares. Back when we were multiplying, if you multiply two binomials and they're opposite signs, you're going to see that their two middle terms, when we go to combine, cancel out. So we only end up with two terms. So if we can start to recognize when we have difference of squares, these are going to be a little bit easier to factor. But it only works if we have three specific circumstances. And I'll go over those with you also. All right, so let me go ahead and share my screen with you guys. All right, my iPad went to sleep on me. There we go. So this is just going back to review multiplying. And the way we multiplied was we mostly used the box method. So I'll use the box method just so we can kind of review, because remember, factoring is undoing the multiplying. It's the inverse. So if I start out with my box, I have two binomials, so I need a 2 by 2 box. On one side, I would put my x and my positive 2, and on the other side, my x and my negative 2. So notice how we're multiplying by x plus 2, and then we're multiplying by that opposite x minus 2. So when we multiply x times x, we would get x squared, and then x times negative 2, we get negative 2x. 2 times x, that simplifies to positive 2x, and then 2 times negative 2 is minus 4. And pay attention that you're always, when these are opposites here, one's positive 2, one's negative 2, anytime we multiply a positive and a negative, we'll always get a negative constant, okay? And then think about what happens with our like terms. This is always going to produce a positive 2x. This is always going to produce the opposite of that term, in this case, a negative 2x. So now when we go to combine these two terms, 2x plus negative 2x or 2x minus 2x, those end up equaling 0. So you're always going to only be left with the first term, x squared, and then minus 4. So this is why when we have difference of squares, there can only be two terms. There's going to always have to be that minus sign, because we know it's always going to produce a negative constant. And then we're also going to have an x squared term, okay? And if you look at these two terms, x squared is a perfect square, 4 is also a perfect square. So these two have to be perfect squares for this to be difference, meaning subtraction of squares, okay? Same thing here. We have 3x minus 4 and 3x plus 4. So again, I'm going to put my 3x and my negative 4 on one side, and my 3x and my positive 4 on the other side of my box. And now we're just finding their products. So 3x times 3x, that simplifies to a 9x squared. And again, see how that produces a perfect square. 9 is a perfect square, x squared is a perfect square. 3x times 4, that's 12x. Negative 4 times 3x, that's negative 12x, and again it produced these two opposites, so they're going to equal 0, and then negative 4 times positive 4 equals a negative 16. So again, those two middle terms, negative 12x plus 12x equals 0. We have a 9x squared minus 16. Again, we only have our two terms. We have subtraction, which means difference. 9x squared is a perfect square, 16 is a perfect square. So that's why this is called difference of squares. So today we're going to take a difference of squares and we're going to factor it back out into those two binomials. Okay? All right, so the requirements in order for this method to work is you must have only two terms. There has to be subtraction, so it has to be difference. And then the two terms need to be perfect square terms. Now you could have a GCF that you could factor out, and then it creates a perfect square and you can continue factoring. And that's what we'll get to tomorrow. Tomorrow we'll look at where we take out a greatest common factor and then we continue factoring with one of the methods we've learned up until this point. Okay, so let's take a look at some examples. So my first example, I have x squared minus 9. Two terms. I have difference, which is subtraction. X squared is a perfect squared, and 9 is a perfect squared. So this is a difference of two squares. So when it's difference of squares, it's really simple. You just need to create your two binomials. Okay, and if you think back to that previous screen where I reviewed, one was always positive, one was always negative. And what's producing the x squared is just multiplying x times x, and what's producing this negative 9 is multiplying positive 3 times negative 3. So all you're doing is you're taking the square root of x squared, that's x, so one x would go in each binomial, and then you're taking the square root of 9, that's 3, so a positive 3 and a negative 3. So this is your final answer, x plus 3 times x minus 3. Okay, number 2, we have x squared minus 16. Okay, so again, check to make sure. Two terms, yes. Difference, yes. X squared is a perfect square. 16 is a perfect square. So I know I have difference of two perfect squares. So this method will work. I'll create my two binomials. I know one has to be a positive, one has to be a negative. The square root of x squared is x, so what produced the x squared was multiplying x times x, and the square root of 16, that's 4, so positive 4 times negative 4. These two numbers have to match because when we combine them in the middle and they're opposites, that's what's eliminating that third term. That's why we end up with just a binomial, okay, two terms. Okay, we have a couple that you're going to try. So if you look over on the right side, we're going to let you try a couple. Just ignore, I'm not sure where this 251 came from. Something, I think that's supposed to be a 25 and there's a 1 there. Oh, it switched places. I'm sorry. Let me just write this on here correctly. So number 1 should be x squared minus 25. I was like, something has happened to my slides. So that's what number 1 should be. So go ahead, and I just want you to try numbers 1 and 2 for now. Oh, you can go ahead and do 1, 2, and 3. So go ahead and try 1, 2, and 3. Make sure you understand this concept. And I'll wait just a moment, let you guys pause the video, work these out, and then you can start the video back and check your answers with mine. Okay, so if you look at number 1, we have difference of two perfect squares, so I can use this method. So I'm just going to come over to the side so I don't run into the next problem. And I see that I'm going to go ahead and create my two groups, my two binomials. I know in order for this difference of squares, my middle term is canceled out, so that means my binomials were opposites. And the square root of x squared would just be x, so x times x, and the square root of 25 would be 5 and 5. So our two binomials are x plus 5 times x minus 5. Okay, for number 2, again, check to make sure it's two terms. This is only two terms. And let's see, only two terms, good. And x squared is a perfect squared and 49 is a perfect square. So we'll go ahead and create our two groups. And we know one's going to be positive, one's going to be negative. I tend to do positive first, negative second. You could switch the signs, that's okay. You have to have a positive, you have to have a negative. Okay, the square root of x squared, x, and the square root of 49, 7. Okay. Go ahead and if you've done number 3, I think I also have number 3 on my next screen, but we'll go ahead and talk about it real quick since I've already told you to work this one out. So if you look here, again, check for difference of squares. So we have our difference, we have our two terms, we have an x squared and an 81. Those are both perfect squares. So we're going to create our two binomials. One's going to be plus, one's going to be minus, and then just take the square root of x squared. So that's x, and the square root of 81, 9, and 9. Okay, so we've covered examples 1 and 2, and then you guys have tried 3. So let's take a look at my next screen. I think I may have messed my slides up a little bit. That's okay. All right, so number 3, you've already done this one, so you can, we won't do that one again. But if you look at my number 3, it's just one more example like we were just practicing. Again, check for difference, yes. Two terms, yes. X squared, perfect square. 64, perfect square. So I can factor this by creating my two binomials, making them opposites, one positive, one negative. Okay, and then the square root of x squared is x, so x times x, and the square root of 64 would be positive 8 and minus 8. And then if I multiplied these out using our box method, it would give us back that product of x squared minus 64. Now, I do want to talk about example 4. Remember I said there's just 3 things we have to meet in order for this to work. There has to be 2 terms. We have that. X squared is a perfect squared, and 4 is also a perfect square. But do we have difference? Okay, we do not have difference, we have addition. And if you think back or look here, what's producing this last term is always multiplying the positive number times its opposite. And there's no way for us to multiply a positive times a negative and get a positive here. So if there's nothing in common between these two terms, what I mean by that is like, do they have a GCF? If they do not have a GCF, you can't factor anything out. This is addition, then we would have to say that this is prime. We cannot factor this. You may see on a test, or if it was like a state test or a multiple choice test, they would either say prime or they may say not factorable. So this one you cannot factor. There are no GCFs, and we cannot factor this because it's not difference of 2 squares. It's the sum of 2 squares. So just be careful there. Now you've already tried number 3. We did that on the last screen. So if you look at number 4, what do you guys think about number 4? Pay attention to that sign. Okay, and hopefully you recognize this would also be prime because we have 2 terms. X squared is a perfect square. 100 is also a perfect square, but we do not have difference of 2 perfect squares. This is a sum. So again, there's no GCF, so we cannot factor this, so this is prime. Okay, and just one more slide today. The only difference here is now we have some coefficients in front of our x squared. Okay, we have some coefficients in front of our x squared. Now this one carried down. My slides are not converting very well to this program today, but that's 25x squared. And I'm just going to write the minus 144 in so we see it kind of all together. So 25x squared minus 144. See if I can get a better focus. There we go. Okay, and so again, check to see difference, yes. 2 terms, yes. Is 25x squared a perfect square? Yes. And is 144 a perfect square? Yes. And again, if you are unsure of that, you can always check on your calculators to see if these numbers are perfect squares. So a few minutes ago, I had that 251 I was confused with. On my last screen, it was a typo that my 1 and 25 had switched places. So if I wanted to check to see if 144 on if you're using a TI calculator, it's second x squared, and then I just type 144, and that's 12, and then second square root of 25, that comes out exactly to 5. So you can check perfect squares using a calculator, or you can make a list of all your perfect squares by just going through and saying 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and just make a list of perfect squares, maybe up to the 12, so up to 144. All right, so we're ready to factor, so I'm just going to cross that out so I don't see that 144 again. I recopied it up top so it all lines up. So we draw our 2 binomials. We know one's going to be positive, one's going to be the opposite, and then now you're just taking the square root of the 2 perfect squares. So the square root of 25x squared, that's 5x. And the square root of 144 is 12. Okay, so this one simplifies to 5x plus 12 times 5x minus 12. And then number 6, again, check for difference. Yes, two terms. Yes, 4x squared is a perfect squared and 25 is a perfect squared. So we can factor this using our difference of squares method. Again, one positive, one negative. Take the square root of 4x squared. So that's a 2x and a 2x. And then the square root of 25 is 5. So plus 5 and minus 5. And that's it for today. You have 2 on the right to try, so I'll give you a moment to pause the video and do those 2 U tries, and then I'll start back the video and you can check your answers with mine. Okay, let's take a look at them. So again, check for that difference. Make sure you have subtraction, and we do. Is 36 a perfect square? Yes. 6 times 6 is 36. Is x squared a perfect square? Yes. And 49 is also a perfect square. We can multiply 7 times 7. Okay, so go ahead and create your 2 binomials. One should be plus, one should be minus. And again, you're just taking the square root of the first term, 36, the square root of 36x squared. So that's a 6x. So what produced that product was we multiplied this 6x times 6x. And then the 49, the square root of 49 is 7. So we multiplied a positive 7 times a negative 7. And that produced that negative 49. Okay, and then the last one you should have tried, again, difference, yes. 2 terms, yes. 25 perfect square, yes. 64 is also a perfect square, and we know our x squared is a perfect square. Okay, so we go ahead and create our 2 groups. And then we take and make one plus, one minus, and now just take the square root of 25x squared, 5x, 5x, and the square root of 64, 8. Okay, so this is really our last type of factoring, other than we're going to start to look at some problems in our next lesson where we have a greatest common factor. We'll factor out the GCF first, and then we'll continue using either our Xbox method or our difference of squares method to continue factoring. Okay, so that will be finishing up all of our factoring. Our next lesson will finish up all of our factoring. And then I'm going to do a day of like mixed factoring review, putting it all together and trying to see, can we recognize when to use which method. I will post a flow chart that you may want to print off. It just kind of helps you think through the process. But that's what our next lesson is on. So we're almost finished up with factoring. And then after this, we'll be moving on to actually solving quadratic equations. Okay. Again, I hope you guys are doing great. Continue sending me messages, email me if you need additional help. Thank you and have a great day.